Before diving into the next two examples, I want to throw out a quick reminder about the product property. What the product property tells us is if we have two powers, let's say, I don't know, maybe 2 cubed, and we multiply that by another power with the same base, say maybe 2 to the 4th. Well, what this is really telling us is I've got 3 of these 2's, 1, 2, 3, and I also have 4 of these 2's, 1, 2, 3, 4, which really means I have 7 total. So the shortcut here is when you're multiplying powers that have the same base, we can just add the exponents. 3 plus 4 is the same as 7. So we don't have to do all this extra work here in the middle, but this is where it's coming from. When you have powers with the same base and you're multiplying them together, the product property says add the exponents. That's going to come in handy in the next example. Man, look at all those 3's. So notice on the left, I have 3 to some power times 3 to some power. So we can still use all of our properties from the previous section. The one-to-one property is the big one. I've got the same base on the left and the right, but also the product property introduced earlier. Because I'm multiplying these two, I can add the exponents. This is one where sometimes people get confused because they think I have to multiply this exponent, this k, times a k plus 2 on the right. We're multiplying the two powers, but the exponents get added together. So I'm actually going to have a 3 to the 2k plus 2, because k plus 2 is 2k plus 2. So that's the trick, if you will, here. We have to use our product property, which is adding those exponents. We didn't change anything on the right. So now what we have is that common base problem from before. Notice I've got a 3 as my base on the left, a 3 as my base on the right. So the one-to-one property lets me set those exponents equal. 2k plus 1, 2k plus 2 will equal 5k minus 1. So that's still just our one-to-one property there. I've got the same bases, so I can set those exponents equal. Now it's an algebra 1 problem. I can subtract the 2k from both sides, pick on the little guy there, 2 is smaller than 5. And if I'm moving all of my variables to the right, I can move my constants to the left. So we can add a 1 to both sides. 2 plus 1 will give me 3. On the right, 5 take away 2 will also give me 3, but on the right that's a 3k. And last but not least, in order to get k by itself, right now I have k times 3. The opposite of times 3 is divide by 3. Goodbye. So 3 divided by 3 will be 1. So k is 1. So again, we used our product property at the very beginning here, which tells us to add those exponents. It's k plus 2. That's where the 2k is coming from. And after we combine those two, now we have the same base. Both have a base of 3. So we can use that one-to-one property, and it's algebra 1 from there. Let's take a look at one more of these before we do something crazy and not have the same base on both sides. So another example where we have 10 to some number times 10 to some number, so we can just add those two exponents together. It doesn't matter that one of them's a -4, the property still applies here. So we have -4 plus 9, which is 5. On the right is where sometimes people kind of go, whoa, because it looks like a binomial, and I'm multiplying, and there's another binomial. Oh no, it's a FOIL problem. We're so used to doing FOIL at this point that we forget that that's not actually what the product property tells us to do. Yes, there's a multiplication here, but I'm multiplying the powers, which is telling me that I need to add the exponents. So the most common mistake people make here is they try to do too many steps at once, and they wind up foiling when all they really had to do was combine like terms. V plus 2v, well that's a 3v. And 4 plus -11, that's a -7. Again, the product property is telling us to add those exponents, we do not need to multiply them here. So that's the real big concept to get across. The other one is the one-to-one property. I've got a base of 10, I got another base of 10. So in order for these two to be equal, those powers have to be equal. So the one-to-one property tells us that 5 equals 3v minus 7. And at this stage, once again, algebra 1. This becomes a two-step equation. We can add 7 to both sides. And we'll wind up with 5 plus 7, which is 12. And then to get v by itself, we can divide both sides by 3. So v will be 4. So again, we start with that product property, adding our exponents together. And then once I have 10 to a power equals 10 to a different power, well, I can take those two exponents and just set them equal. So if you have questions, comments, concerns, or feelings on any of these first 4 examples, let me know. Otherwise, go ahead and try the practice problems that are attached and see where you're going to need help, see what kind of things you want to see again, maybe extra examples of the properties. Whatever you need, just let me know. Definitely start the practice problems before moving on to the next section, because after this, what we're going to do is not have the same power, part of the same base on both sides, and see how to tackle problems like that. So I'll see you soon. Take it easy.